This is the Geodimeter 140. It's made in like Sweden, I think, and this model came out in 1981. This particular unit has a backup battery in it stamped 1988, so I suspect it's a 1988 production unit. Basically, we've got our two locks for our fine tunes, and let me just kind of turn this for you. There's its axis alignment. Of course, they had to put their logo as the axis alignment sticker. This is the transmitter. Oh, this is the transmitter. You can see that purple dot in there. I wonder. Yeah, that's the infrared transmitter for the rangefinder. This is the receiver. It's not integrated into the telescope like a modern theodolite. This is the actual optics that you look through. And it's got a little light in there that you can turn on. And here, of course, is the fine tune adjust knobs, the fine alignments. These are non-optical encoders. I guess they're some sort of high-frequency magnetic encoders. They're pretty proud of them. And of course, we've got the little bubble level down in here. They actually, you can see how there's like a red sheen reflection on here. They actually put an IR reflective coating on here to keep the sun's infrared from going in there and heating up the bubble, because when the bubble gets heated on one end more than the other, that makes it go out of level a little bit, even if it's level. So this is the user interface. Well, of course, this is the lens. You can look through there, and look, my backlight's on. That's why that red LED is showing. Anyway, this is the user interface. This is the volume knob right here for the beeper. Let me show you the beeper. Let me go to the right angle here. See, it's got this little meter and the beeper tell you how much of a reflected signal you're getting off your retroreflector, which is just a piece of reflective tape out there that I got. So you can see the pitch. It tells you if you've got a good reflected signal. Anyway, this is the volume for the beeper. This controls the ppm, so like if you're in standard atmospheric, standard pressure, standard temperature, you set that to 0. And they actually came with a little rotary slide scale calculator, so you can take your air pressure. You can set your air pressure down here, your barometric pressure, and then you pick your temperature up here. So for example, if it was 750 millimeters of mercury of air pressure, I'd set that right there, see? Then and let's say it was 80 degrees out, 80 degrees Fahrenheit, right here. That maps to 10. So I would then set this knob to +10 to compensate for my specific temperature and pressure. But it's not 80, it's more like 60 out here, so I'm going to put this back to 0. Okay, this knob here, you can click to different things like that's off. 8.8 is the test and configuration mode. Well, you go through some self-tests and do the calibration routines. This is just standard surveying mode. And then that's a prism there, so that puts it into prism mode, where you can then bounce a distance off, so I'm going to go ahead and do that. And this is the cycle button here, so I'm going to touch that. It's pretty sensitive. So now it measures the distance. It's measuring the distance. It's not fast like those modern ones, but okay, it measured that target out there at 339.45 feet. I'll just give you a look through. There it is. You can see it out there. The white part is the reflector, which I have above a black mark that I have the crosshairs on. And now, let's say we want to read, so this is our slope distance. That's just the straight line just the straight line from the theodolite or the total station to the reflector distance. If I want to measure the horizontal distance, I switch this up to here. See, there's a little bit of difference between those, not a lot, because it's a pretty shallow slope. If I want to measure the vertical distance, I put it up to there, and so that reflector out there is 8.61 feet above me. That light there just means that it's getting a signal from the reflector. So now let's say I want to see the vertical angle. I press and hold this, and when that flat flashes, then I let go, and now it's showing me the vertical angle down from, or the vertical angle down from straight up. So it'd be 90 degrees if it was straight out, and more than 90 degrees if it was below eye level, but that's above eye level, so it's showing as, look at that vintage vintage readout. And press this to go back to horizontal reading. I zeroed my degrees there, but you can see basically, let's see here, let me just get this right at, basically it's degrees, minutes, and then seconds. So it's 359 degrees, 59 seconds, or minutes, and 54 seconds is how that reads out. That steady light means it's a horizontal reading. And that's about it. Well, so this little switch here switches on and off the automatic level compensator. And right here, which you can't really see, one of those holes I think is for the beeper. The other is, okay, let's see. One of them's a microphone, because this actually had a feature where it has a microphone and it transmits a voice signal. I'm not sure if it does it. It must do it on the, yeah, it must transmit a voice signal on the infrared range-finding beam, so that your rod man out there could have a special receiver and he could hear you talking to him to step right or step left or something like that. I'm not sure how that worked. I don't have that part of the system. And of course, you never ever had your battery in an old contraption like this. So it's got a swivel and a DB9 port right there, and a cable that goes down to a big old battery. And of course I didn't have the right battery, so this is just a lithium-ion pack I built up some time ago. It runs on 12 volts. I'm running it on like 14 volts. Well, it goes down to 12 as the battery gets dead. So anyway, there you have it. Brand new model in 1981. Oh, I forgot one feature. To zero your horizontal axis, you press this button, and you can choose between zeroing or freezing. So if the switch here is set to the 0 mode, then when you hit that, it just zeroes your horizontal axis to wherever you're pointing it, it zeroes it. If you switch this over to reference, that allows you to freeze and unfreeze the horizontal angle. So like if I want to point it, if I want a certain horizontal angle, I can you know, let's say I want to set the thing to like 42 degrees. whatever. I point it where I want it. Then I press this freeze button. It beeps at me. That froze the angle. See, now I'm pivoting it back to wherever I want it. And now I can press that button again and unfreeze the horizontal angle. And now I'm reading live angles again, but it let me set a given angle for my reference. Or you can just put it to the 0 mode, in which case pressing that button zeroes it right out. It's 0 there. It just moved because I was leaning on it. Alright, that's about it. Oh, it does have an optical plummet. Where did it go? But it's built into the this thingy. Tribrock, however you say it, whatever it is. It's just built in here so you can look through here and... Ah, there's my battery down there. Yep. It's just looking down at my battery down there. So that's all the things I can think of here. What's the sticker say? Made in Sweden. Yep, I thought so. Look at that.